Okay, today I'm going to be showing you the magnifying transmitter in the dark. Okay, so I have been working on the magnifying transmitter all day long, and I've actually decided to tune it to a different frequency. This frequency being 168 kilocycles, or 168,000 hertz. Okay, so the power comes in from this transformer, which I have reversed to step up voltage. And then it goes into these capacitors and the inductor or primary of the magnifying transmitter. This is known as the LC circuit or inductance capacitance circuit. So this part is tuned to 168 kilohertz or 168,000 hertz. Once the current goes through the primary, it's induced into the secondary, which is tuned to a fourth of the wavelength of this frequency of the primary. And then the bottom of the secondary is grounded to the earth, and the top goes into the extra coil, which is tuned to the coil's natural resonant frequency. And the ball on the top acts as a capacitor to help tune the whole system. So if anybody wants to build a coil that is tuned to 168 kilohertz, you will receive my electricity as long as the coil is connected to the ground somehow. So this coil right here is tuned to a harmonic of the earth, and it creates standing waves in the earth. If you've ever heard of standing waves in a string, this coil creates standing waves in the earth. So there are nodal points. Okay, this is a correction of something I said earlier. If you want to receive the electricity from this coil, you must wind a coil a fourth of the wavelength of 168 kilohertz. Okay, if the coil is working very well, the neon light bulbs should not light up all around me in the air, because all the electricity will be going into the ground. Okay, now I'm going to throw the switches. Okay, this is an example of a receiving coil. So this length of wire needs to be a fourth of the wavelength of 168 kilohertz. This is your secondary. Make sure you ground the bottom of the receiving coil.